matrix representation of a graph. Matrix representation of a graph. We can draw a graph. By the help of given vertices and edges. First is adjacency matrix. And second is incidence matrix. Adjacency matrix and second is incidence matrix. Right? First is adjacency matrix and second is incidence matrix. Now what is adjacency matrix? The adjacency matrix of a graph adjacency matrix of a graph G with n vertices. G with n vertices and no parallel edges. In an n by n is an n by n symmetry is an n by n symmetry binary matrix. Symmetric binary matrix X equal to Xij n by n. X equal to Xij n by n such that Xij equal to 1. Xij equal to 1 if there is an edge. If there is an edge between ith and jth vertices. Ith and jth vertices equal to 0 otherwise, right? Xij is an n by n symmetric matrix such that Xij equal to 1 if there is an edge between ith and jth vertices and 0 otherwise. Suppose we explain it with a graph, with an example. Suppose This is a graph. This is V1, V2, V3, V4, V5 and V6. This is E1, E2, E1, E2, E3, E4, E5, E6, E7, E8, right? E8. Now the matrix is total number of rows and total number of columns is equal to the number of vertices. How many vertices is there? 6 vertices. V1, V2, V3, V4, V5 and V6. V1, V2, V3, V4, V5, V6. Now see that V1 to V1 there is no self loop. So V1 there is one element is 0. One element is 0. Right? V1 to V2. V1 to V2 there is an edge, so it is 1. V1 to V3. V1 to V3 there is no edge, so it is 0. V1 to V4 there is an edge E4, so it is 1. V1 to V5 E7, so it is 1. V1 to V6 there is no edge, so it is 0. Then V2 V1 there is an edge, so it is 1. V2 there is no self loop, so it is 0. V2 V3 there is an edge, it is 1. V2 V4 there is an edge, so it is 1. V2 V5 there is no edge, it is 0. V2 V6 there is no edge, it is 0 also. Then come to V3 V1 there is no edge, it is 0. V3 V2 1. V3 there is no self loop, 0. V3 V4 there is an edge, it is 1. V3 V5 it is also 1. V3 V6 there is no edge. Then V4 V1 1. V4 V2 1. V4 V3 1. V4 0. V4 V5 1. V4 V6 0. V5 to V1 1. V5 to V2 0. V5 V3 1. V5 V4 V3 V4 1. V5 0. V5 V6 1. Then V6 only there is an edge between V6 and V5. So all other elements are 0. So this is the adjacency matrix of this graph G. Now some criteria of this matrix. The following observations we can find for an adjacency matrix. Number one, the elements in the principal diagonal. Look, the elements in the principal diagonal is 0. The elements in the principal diagonal is 0. Number two, what is the degree of V1? 3. What is the degree of V2? 3. What is the degree of V4? 1, 2, 3, 4. Degree of V4 is 4. Look, at the first column, that is V1 column, there are only 3 ones. There are only 3 ones equal to the degree of V1. Again, in the column of V2, there are only 3 ones equal to the degree of V2. That is, we can write the number of ones in a column is equal to the degree of each vertex. Number of ones in a column is equal to the degree of each vertex. So, if there exists an isolated vertex, how many ones we can get in a column? 0. Because the vertex is isolated, so there is no connection with any other vertices. Number 3, the matrix has no identical columns, or rows, because there is no parallelism. We can see that in this matrix there is no identical rows or identical columns, since there is no parallel edges. Number 4, permutations of rows and of corresponding columns. Number 4, permutation of the rows or columns imply the rearrangement of vertices. Right? So this is all about the adjacency matrix. Now we can draw a graph with the help of the adjacency matrix. Suppose there is no graph, but there is an adjacency matrix. So we can draw the graph with the help of the adjacency matrix. So this was about the adjacency matrix. Next class we come to the incidence matrix. Right?